This is what we.
So welcome everyone to your ALC training seminar. We can either take a look at what's here on the graphics and then do a walk around just to see where all the equipment is first and answer any questions as we go.
That sounds okay with you guys?
Everybody looks comfortable. So as we see, we've got first floor, second floor, and then the section set up outside, which isn't primarily designated. You've got your 5 units. The green light here, as opposed to the white, this will be between white and gray on these two because there's not a thermostat directly connected to them, whereas these units are ran off of a specific direct temperature. Okay, so that's why you would have the difference here. The same as the rooms that you see because they're temperature controlled primary. We can zoom in and we'll take a look at first floor graphics, which is a little bit of a closer view. We've got the rooms laid out where the spinning room is. We've got the men's room.
Hello.
Sorry,
Thank you.
Please. We have an extra chair.
The language has
Thank you.
changed now.
Sorry, we decided this was a good use of your new room.
I think it's a great idea.
So-
I wish we had new furniture.
So then for the second floor, let's see a close-up of the second floor. We actually have a picture of the D-strap fans, and then the different rooms laid out in their sections, as well as the electrical room, and then the mechanical, again, just the color of lights. You can focus in on the graphics in some of the specific rooms. The home meeting room, which is what we're in right now. You can see a graphic with the thermostat through, I believe it's a 12-hour period. You'll be able to see what the temperatures are coming in from its occupied to unoccupied. As the set point changes, you'll see this be lower and then higher. Right now, this may look like a big jump, but it's between 68 and 68.5 degrees. So the room has been actually maintaining pretty consistently.
That'll be staff.
What was your question?
He's looking at the stats, not a slide on it.
No, it's not.
The other two are. Like the roasted chops.
What you are.
We'll make note of that. Then we've got a picture of the staff meeting room. Same thing, that one looks like it's been maintaining close to about 70 degrees, which is right in between the 68 and 74 that we're looking for. Visitor meeting room.
Yeah, Martha, you're gonna have to let us know how the temperatures are, if they're comfortable or not here. Because they were 70, and we lowered a lot of the rooms in here to 65, because especially upstairs in the mezzanine, they're complaining too hot. So-
My guess would be that these rooms, if they're being used between, like at halftime of the game, we don't want them to get chilled.
Yeah.
So we might want these a little bit warmer
Like
than
68 or something like that?
yeah, than the field house.
Okay. And the mezzanine, we put the 65 up top, side by side, and the spin room.
Spinning room, you see your set points to the spinning room. Heating at 65, cooling around 74, which that's all, adjustable just by clicking on here and changing it to whatever the desired value is that you would like. You'll see your hot water valve percentage, what the unit's discharging. This is the amount of airflow that's coming out. The damper position, as you can see, the blade is almost fully open, so you've got 63% there. And then this discharge air temp value, that actually is what's coming out of the air handler at the moment. We're going to alter this graphic so it spells out specifically AHU10, which is where it's getting its airflow from. Women's room, which is the women's bathroom. There's a piece of radiant that's in the ceiling, just demonstrated by this segment here, and you can see whether it's open and closed. This wild graphic here, it's showing you it's between 70, 75, 70.5 after that, so we're still maintaining, even though it looks like it's a little out of control. The vestibule section, which there's a standalone cabinet unit heater. So all we're really doing is monitoring that space for alarms. So just in case it does get too cold, we're going to be able to see, that and get an alarm back, to facilities.
Do you have any proof that that's running, Mike? No.
We don't. We're actually not seeing any proofs on those units. So we'd be, if you notice that the space temp tanks or, in the wintertime, that's when you would know that there was an issue with that
And
space.
is there an alarm set point on that? Or?
Yes, let's take a look at what that is. So right now, your zone temp, if you see in this section here, so your cooling would be at 85 before it goes into a high zone temp alarm, and then right now it's 5 degrees below the set point, which is 65.
Okay.
And that's what will set off your low zone temp. And these are all adjustable. So if you find that you're getting nuisance alarms, you can lower that down, or the same thing with the timer block that's in here. We can, expand that a little bit, say that the unit takes a little more time to adjust to the conditions in the space.
Are the reheats labeled with the number of the reheat and what air handler it's tied to? At the unit?
So the reheats are going to be in the spaces themselves. So their coils come back off of the main hot water system. So the boxes themselves is what you're asking? If the
Yeah.
VAV boxes talk about what the air handler is?
Yeah, I just wonder if they're labeled and tells you which air handler.
I'm not sure because there's only the one air handler that feeds the VAV boxes here, which is air handler 10.
Oh, okay.
Yep.
The others don't, that didn't change, they just dump into the field house.
Correct. Yep. Good question. Go back to the graphics for a moment. Switch over to the men's room. We can see there's a piece of radiant in there, cooling between, heating at 70, cooling at 80. Looks like there was a little bit of a drop around here, so it's probably 68 and a half. We can, if you guys want, you can actually expand the graph and get a little clearer picture of what's going on. So you see that it dropped about 68 and a half and has been coming up since, which is why we would see that the radiant valve here is open. And we've got a picture of the D-strat fans.
Can you change the graph parameters? You have them going by half a degree. Can you make it larger so it's a less dramatic?
So if you, you can zoom in and out, and that will, so this would zoom in on functions of scale to fit. Yes, you can. There is a way to zoom in and out on it. To zoom out to make it look less dramatic.
Okay.
But they show as a scale to fit.
Okay.
So if it's moving between a half a degree, it zooms in on that
Right.
amount of space to just show you what it's at. So this is what the D-strat fans, the way the D-strat fans work, I'll show you, you better see in the window. So you've got 3 thermostats set up high. One is by each fan to see what the temperature is up there. And then you've got 3 thermostats set down low, which is on the side wall here. It's almost like 1/3, 2/3, and then down the end for where those are spaced out. And what they do is they're trying to maintain a 5-degree differential between what's up top and what's below. And that determines what the fan speeds are.
Does Dennis and Billy have control of those stands or no?
Yes.
They do?
Yep, through integration, you'll notice that this number seems a little out of whack. The Yasukawa drives actually look for 100%, or 100 command to them is actually 10%, or 10 hertz to the drive. And a 600 command is 60 hertz to the drive. So I'm going to change in the program, we'll do a little division so it'll actually depict a little clearer what's there, because seeing it at 250, it's not spinning at 250% of what the fan's rated for. But yes, they do have full control. So if we go to properties and our network points, because this is actually, we're integrated to these at the moment, so we're not directly connected inputs, outputs to our controller. It's through a network program that we have it, and we're able to move, whether we want them to go forward and reverse, which it's set up for summer or winter in that, for that function. And then you have your VFD speeds on the 3 drives, and then your feedback and frequency from there.
Are you able to vary the speed one to the other, or if you make the adjustment on one, does it affect all 3?
Right now, we have it going, it is individual, so you can change one alone, but through the programming, they all work in unison. So if we wanted to change that around for some reason, if we wanted to limit that, we could.
Can you shut one off and leave two on?
Yes. Is that a request or just a question?
It could be a request. If
Okay.
we're having a volleyball match, we may want to shut the one over the volleyball court off.
Yes, that is possible.
So where are the drives?
They're in the ceiling. So.
Up near the air handler 10?
No, they're in the field house ceiling. So the drives are mounted within 5 feet of where the fan post actually is.
How good are you climbing?
Don't worry,
You're gonna have those.
eye hooks, we have eye hooks there, right next to them, so we can climb up.
You gotta get there first.
Where's Sully?
An eye hook, what's an eye hook gonna do? What, are we George in the jungle here, or
Yeah,
what?
the way you have to do it is you have to bring a lift in and do it from a lift, that's
Yeah.
really.
So those drives, you don't have to manually go up there, you lose power or anything, it's not one of the drives that has, you have to go and reset it.
No, we've seen power go on and off when they
Okay.
were cycling for, the different tests that they were, the power tests that they were
Yeah.
doing, that the units do come right back up.
So that's working quite well.
As well as fire alarm, Jim, they shut off on fire alarm.
So there's a shunt that shuts those
Yep,
off?
but they're tied into the controller that's down over here in the last storage closet.
Yep.
And as soon as you reset the fire alarm, the fans kick back on.
So there's an output from my card from, or I take an input from the fire alarm device. So when the unit goes into alarm or he sees I don't believe it's a trouble, when the units go into an alarm, it sends that input into the card and then the card translates, remove your run command from the fan, and then the fan shut down.
You want to explain to them why we're in the summer mode? Because they're gonna look at that the rest of the time.
Yes, so we're in the summer mode because we're doing an experiment.
We're not necessarily doing an experiment. The fan manufacturer says that the direction of these fans right now is summer mode. The engineer, RFS, disagrees with that and says that the fans should push air down in the winter and air up in the summer. And that's what they desired. So the fans are spinning per design by the mechanical engineer the correct way right now.
All right, well then let's change that around.
So you're saying we should be in the winter mode then?
Yeah, I think he's just gonna change the way it's worded right now.
Yeah. The way they're spinning is now is the way.
Oh,
Correct.
okay, I understand.
If you go to the Macro Air website, they've actually got a very nifty YouTube video of how the fans are supposed to work. And their thought is that you push air as fast up through the ceiling and it'll move the air down. But that's not what RFS wanted. So they're spinning, right now they're pushing hot air down, which intuitively to us would make more sense that, like a ceiling fan in your house, so you can reverse the direction. It's very similar.
All right, so I'm actually gonna have to go into the programming to change that, so that'll be a little bit, but that will get corrected. So that as they spin right now, this will be winter mode, and then to reverse it, it will be summer mode.
Good.
Good question.
Do you know what voltage these fans run at?
I believe it's 480, but I'm not certain about that. 277,
Probably 480.
that was my thought.
Yeah, I think if you can reverse them, they're three-phase.
So now we move up to the second floor, as we saw. Here are the mezzanines. You can see the same thing with your high airflow, low airflow, which come through these blocks. Your damper being at 45% open. Discharge air temp from AHU10, 60 degrees. Thermostat, reading for your temperature. And is what we had changed earlier to try to make them a little more comfortable upstairs. It's now a 65-degree heating set point.
When you say thermostat, they're just sensors, there's no remote control.
Martha, we just changed those, just let us know what you.
Yeah, no, but I mean, if there's somebody can't come in and turn them up.
Is there a slide on those upstairs, or are they just?
It looks like there is, based off of this, that actually is an adjustable set point, but what they have is 2 degrees up or down.
Okay.
So it's not anything real drastic, you know what I mean, 65 would be 63 or
It's got a dead
67.
band, whatever, it can,
2 degrees, which is adjustable, and if you find that people play with that a lot, and you don't want them to play with it, you can actually remove that through software. So if they can move it around, but they don't actually get any changes from it.
Is it 2 degrees either way? So it could it go 67 to 63?
Yep. Yep, so as we see here, this one is set up for -2. You see the program actually already adjusts it for 63.
Okay.
So this tells you what it's normally set for. This tells you with the adjustment what it's at. So I believe this has been set -2 all the way across the board because it was at 70 degrees beforehand and everybody was trying to bring it down a
Yeah.
little bit.
So you might have to go around, put them back up in the middle or something.
Do we need to do that, or should they stay?
You don't have to do anything if you don't want to. If you start getting complaints that they're too
Some
cold.
of the complaints are still that it's too warm and not enough fresh air.
But right now, when we drop the set point to 65, if you start getting complaints they're too cold, just grab the slider and bring it up, because we're dropping it down a little bit.
So you're still, these rooms are still sitting at 69 at the moment. So it's gonna take, I mean, from, you know, with a 61 degree output, 69 degrees, it's gonna take a little bit for it to bring that down.
Can you tell how much outside air or how much fresh air is being introduced, I guess, to Martha's question?
At the moment, yes. Yep, if we move up to HU10. So what you can see on here is that you're bringing in 2,400 CFM of outside air into the unit. And you're returning 4,900, some of which is getting expelled, some of which is being returned. So now you're looking at 3,800 coming into the unit. So you're expelling 1,000 CFM out, whatever the difference is here with this is what you're expelling. So you're bringing in 2,400, 2,500 CFM of outside air into the building.
Is that appropriate for a fitness space? I don't know the answer to that.
That is what it called for in the spec. So that's appropriate to what the engineers believed.
Which, to answer your question, well, it should be on usage, the engineer. We can question that, but the design criteria would be count that it is a fitness area, and so it should have the appropriate fresh air for that space.
But we can, is there ability to adjust that if we need to, or not?
At this point, this is based off of what that damper size is. When we can start, right now we have the outside air closed just because of how cold it's been. It's calling, you know, with this much outside air, we're actually seeing a 37-degree mixed air temp. And in order to protect what's going on, they close off the dampers. But as the temperature starts coming up a little bit more, this will start to open, which allows more outside air in. So you actually have 3 sections coming in from the outside. 2 of those are closed off because this is what the minimum requirement for outside air is right now. And that's 100% open, so 2,500 is really what you're bringing in from the outside. So I don't know if that answers your question. So finish up with the second floor.
It also has a CO2 on it too, so that would take an adjustment to that.
So as the CO2 increases, it'll determine at that point that it does need some more outside air, so then it will start to react appropriately. We got the balcony section. Same thing, it's trying to go into cooling mode. You see that the reheat's closed. And then the electrical room, which are doing the same thing that we are in that the mezzanine spaces. We're just monitoring the temperature inside the electrical room to pick up alarms. And I believe that the alarms are set up for the same plus or minus, yep, so plus or minus 5 degrees from the set point. So you've got 60 degrees is your low zone temp, and then 85 for your high zone temp. I'll look at HU5. So these are ran off of their return air temp. So it's not actually a zone temp that's in there, but it's, you know, drawing the air into its return plenum measuring what that is and trying to maintain that. So right now, they're looking for 60, we're getting 62, which I feel is pretty good. 25% outside air coming in, 75% is what it's returning through. We've got our mixed air temp at 60 degrees with the hot water valve, free stat for protection, and then our CFM to know what we're registering for airflow. We're discharging 61 degrees into the space.
Does that seem like a good temperature out there?
Did you say what does that air handler serve? I'm sorry.
Oh, I'm sorry. So air handlers 5 through 8, which are the next 4 that I'm going to show, those are the field house air handlers. So, and I believe it goes, our closest one is 5, 6, and then 7, the closest one on the left side, 8, the further one back by the garage doors. I believe that's correct.
And the exhaust damper?
Yep, and then this is the external dampers, which are the dampers on the right side of the building, by the street. Those 4 are run through these controls. And you'll notice, as we see here, you've got your outside air temp and your outside air humidity. Now that shows up on every page, so you can always know what the temp is outside. Air handler 6. You see it's roughly doing the same thing. It's a little bit warmer over there, 63 degrees. Your CO2, 385, 75, 25, which these work inversely to each other. So as this closes, this one opens to try to keep a consistent amount of air. Same thing, our mixed air temp 56, the hot water valve circulating, 60-degree discharge temp. And that would take care of the 2 on this side, 5 being closer, 6 being further away, 7 being our closer unit on the left side. You see that one's bringing back 64 degrees. We've got 80%, 20%, 61, 6,000 CFM. You'll notice that our VFD and what we have for it, so we've got a flow status, which means it's running. Our feedback is an amperage. Speed is at 15%, so it's set up for its lowest command, which is the 6,000 CFM at the moment. And you notice your status is normal and your faults are normal.
Was anything done with the filters, the fresh air filters?
I'm not sure, Chris, for the question to you.
Yeah, the fresh air filters were replaced once, and then Pinnacle's actually got more filters on order to replace them as well.
And lastly, far back by the garage doors is HE8.
As part of the, I'll follow up with that too, as part of our project, our scope of work on those old units was to come in and clean the ductwork. So during construction, the units were shut off. The return air plenums were taped off with a filter fabric to prevent anything from going up there. And then once we had the bulk of the construction work done, we had hired a company that came in through Pinnacle, a duct cleaning service. They came in, cleaned all the ductwork, refiltered them, and then, like I said, Pinnacle's actually got more filters just to give you guys a fresh, brand new set.
And what we tried to do is to make this program an exact replica of what was here before, so how the Hansa units was controlled beforehand. So in our alarm monitoring section, you've got this loss of phase. So if you lose voltage at the controls, you're actually going to get an alarm. And the same thing, if someone goes up to the units and they switch it from auto into off, because you guys need to work on the units, they're actually going to know back in the front end. So if, say, you're in a rush, you leave, you forget that it's in there, someone's actually going to know that it's not in auto at the moment. So if the unit's not running, they're playing with the software, this is kind of a nice way to tell, you know, what function the unit is in at the moment. And HE10, which we looked at once already. So you've got your minimum outside air damper, which has the flow station to monitor what's coming in. And then you've got your other 2 sections, which are set up right next to it. And we'll take a look at this when we go upstairs at the unit. This comes in based off of what this temp is. So this doesn't open if this starts seeing below a certain temp, which I believe is 45 degrees. Once it starts seeing 45, in order to protect everything that's in there, it starts closing off these 2. to make sure that we don't have any problems. Your return fan is tracking your supply fan. Right now, we've got it about 15% shy through programming for what it's seeing in order to maintain a little bit better. You notice we kind of have a negative in the spaces right now, so we're just kind of playing with those numbers right now in order to balance that out. You've got your duct smokes inside, taking a look. You've got a safety for your supply fan high pressure. Because this says VAV units, you need to have this in place. We're running off of a balancer supplied set point of 0.55 inches water column, which is actually the pressure inside the ductwork. So that determines how much airflow we're bringing into the VAV boxes. And you also have a set of alarms here, which is high and low discharge air temp, high supply duct static, low supply duct static, which is this number here. So if the units start ramping way down and they're not supplying enough air over, I think it's over 10 minutes or so, they'll actually get an alarm back. You know, there's something going on with the GFDs, signals conflicting or something like that causing it to be low. You also have a dirty filter alarm. So as this starts to approach 1 inch, this will go gray, and then you'll actually start to get an alarm coming back saying, hey, you know, it's time to change your filters.
Is this a Hansa unit?
This is not. This is actually a train unit. And then your freeze stats, which you have a reset on. If this goes into freeze, it's not a manual reset device. It would be wise to go up and take a look at the unit to make sure that nothing's burst before you click this button. But then you would come back to the front end or, you know, wherever, if you've got a tablet in front of you or you're looking at it through your cell phone, then you will have to, through software, click this reset button. And then as long as the device itself has actually been cleared, as in it's above 38 degrees, you'll be able to hit that, reset the unit, and then it will start back up to its normal start procedure. So our outside air conditions page. So this monitors our today's highs and lows, monthly highs and lows, and then our year-to-date highs and lows for what we have. So we saw a balmy 0 degrees on the last, or what was that, last Saturday? Here's a graphic of our hot water. So we've got our heat exchanger here with our 1/3 and 2/3 valve. The 1/3 opens to, the 1/3 starts looking for its temp before it calls this on. This obviously needs to get up to 100%. Then once that happens, it pulls in the 2/3 afterwards. You'll see here through your pumps that you've got your start command, your status, your feedback in amps, which the status is based on your feedback in amps, the percentage that the pump is running on, and then your status, whether it's failed or if the VFD itself has been in fault. There's a lead lag on this, so your pump 1 will run for a certain amount of time, which I'm not certain as to what that is, and then your pump 2 will run, you know, afterwards to pick up.